Hi everybody, today's lesson is about logarithmic functions. So you might need to pause to write this down, but our goal today is to rewrite and evaluate exponential and logarithmic expressions. So you're asking yourself, I bet, what are you talking about? What is a logarithm? Well, a log, we call it a log for short, L-O-G, is a quantity representing the power, or exponent, to which a fixed number, the base, must be raised to produce a given number. So I know this sounds pretty fancy, but what I'm basically trying to say is a log is an exponent. And you'll see what I mean in just a minute. So, exponential form. We have seen many exponential equations, and I'm going to write this as b to the y equals x. So all of these could be any number. It could be something like 3 squared equals 9. Anything with a base and an exponent is something in exponential form. Now we can go between exponential form and logarithmic form pretty easily. So logarithmic form looks like this. It's log base b, and make sure your b is small, and next to that log they go together, of x equals y. And so if we look at our exponential form, this y was the exponent, and it still is over here. It is our exponent, or sometimes we refer to that as a power. So remember up here when I said a log is an exponent? Well, this log equation is equal to an exponent. And all of these numbers relate to each other. So I know that b is the base, y is the power, and then we had that given number up here, right? Must be raised to produce a given number. Well, x is that given number. We want to know, b is the base, what power do I need to get to that number? That's really what I'm asking myself. So over here I made this chart. And I'm going to show you how you can go between exponential and log equations. So it's important to know how we read a log equation. And I'm going to write it in quotes. We say log base b of x equals y. That's exactly how I would read this out loud. Log base b of x equals y. And so I always say that in my head when I'm trying to write out this equation. So here is an exponential equation. Actually, all of these on the left side are going to end up being exponential equations. We have to know the base, the power, and the given number. So we all know that 2 is the base. So I'm going to write log base 2. Again, that 2 is small, little subscript of the log. Of the given number is 1024, because it always must equal the exponent, right? The log expression is always equal to the exponent. So that's pretty easy. Let's try the next one. It all follows the same format. So again, the base is 2, so log base 2, and I'm really just reading this sentence out loud. The log base b of x equals y, knowing that y is the power, which is also the exponent. So log base 2, we're going to say of 1/8 equals -3, because I know that my equation must equal that exponent. And then we'll keep going. So now my base is 1/2, and that's okay. Bases can be anything. Don't get scared because it's a fraction. But again, remember that 1/2 is a small subscript of the log. So log base 1/2 of 128 equals -7. So base, given number, exponent. Base, given number, exponent. It all matches in a very specific spot. So then this is my last example of going from exponential to log form. So here my base is 5, so log base 5 of my given number, which is 625, equals 4, which is my exponent. And they must match. So that's how you write exponential to log. And I know it might seem weird because it might be the first time that you're seeing this, but it's just part of that definition we decided up here. It's always log base b of x equals y. Log base b of x equals y. b is the base, x is the given number, and y is the exponent and or power. Okay, so now I've given you log equations, and we can always go in the other direction. Now I'm going to take my log equations and write them in exponential. You're allowed to go between the two as much as you want. So I kind of make a little circle here, so I know that my little subscript is the base. So 3 squared equals 9. So base is 3. I know that from the fact that it's a log base 3. That's why we say base. Then I know the log is equal to the exponent, and then 9 was my given number. So we can do this over here too. Let's do one that we already did. Let's go back to this first one. 2 to the 10th power equals 1024, which is exactly what I have. 1/8, base is 2 to the negative third equals 1/8. 2 to the negative third equals 1/8. So you can always go back and forth. So here I've got 8 to the 0 power equals 1. And you should always ask yourself, does this make sense? Does 3 squared equal 9? Yeah. Does 8 to the 0 equal 1? Yeah. If it doesn't make sense, then we probably did it wrong. So here base is 5, exponent is negative 2, and that equals 1 over 25. And here my base is 10, my exponent is negative 1, and my given number is 0.1. So you do need to know this up here and over here. This is important. It's part of the definition, and it's the only way you're going to be able to rewrite it. And the more you do, the easier it becomes, and you might not have to refer back to that stuff. But the important thing is you can always rewrite equations to be in the other form. You can always, always, always go back and forth between the two, depending on what you need to do to solve your problem. So let's move on, and let's evaluate expressions without a calculator. This is important because on your test, you're going to be given a non-calculator portion, so you have to know how to do it without one. So there are steps. Assign a variable, write the expression in alternate form, and solve by getting the same base on both sides. So when I say assign variable, I want to evaluate this. I want to know, what does this equal? So your variable can be anything. It could be x, y, z, l, p. I'm going to use a question mark. And then it says to write the expression in alternate form. So this is a log expression. And we know that because it says log. So if it's in log form, I want you to change it to exponential. So that means 3 to the question mark equals 81. And then step 3 says solve by getting the same base on both sides. So 3 and 81 are not the same base, but I know that 81 is 9 times 9, and 9 is 3 times 3. So I'm allowed to rewrite 81 as 3 to the 4th. So once they have the same base, I'm telling you that 3 to something is the same as 3 to the 4th. So what that means is my question mark is equal to 4. It has to. The only way those two things can be equal. So log base 3 of 81 equals 4. Alright, let's do part B. This time I'm going to say equals x. Makes more sense to use x instead of a question mark, but again, you could use whatever letter that you want. So again, that's my assigned variable. Now I'm going to write it in the alternate form. So that means 1/2 to the x power equals 8. And here's where things get a little tricky. I've got a fraction and one that's not. And I know that this is base 2 and this is base 8. So that's not going to work for me. But there's also something to be said about the fact that I have a fraction and a whole number. So I'm just going to write this as 1/2 to the x power equals 2 to the 3rd. Because we know 8 is 2 to the 3rd. But how am I going to get these to have the same base? Well, I know I'm allowed to distribute this exponent. So 1 to the x is over 2 to the x. And then my 2 is on the bottom on the left side, so I'm going to move it to the bottom on the right side. So then my exponent becomes negative, right? If I move things from one side of the fraction to the other, the exponent becomes negative. And then the last thing I'm going to notice is that 1 to the x power is just the same as 1, right? 1 to anything is just 1. So now I have 2 to the x and 2 to the negative 3. So x equals negative 3. Again, if you need to rewatch that, please do so. Now I'm going to say equals x. So 5 to the x power equals 1 over 625. And I know I'm always looking for the same base. You know, that sign variable, step 1. Step 2, write it in the alternate form. And 3, I need to solve by getting the same base on both sides. So 5 to the x is the same as 1 over 5 to the 4th power. If you break down 625, it's the same as 5 to the 4th. But 5 and 1/5 are not the same, so I need to bring this 5 up. So 5 to the x equals 5 to the negative 4 power. That exponent becomes negative on the other side of the fraction. So x equals negative 4. Now, I'm just going to tell you, for part D, let's say I say this is, I don't know, I'm going to use a question mark again so I don't confuse anybody. So if I write this in another form, I've got 3 to the question mark equals 3 to the 2x. So that's the same base. That means my exponents must be equal. So 2x is my answer. But there's actually an easier way to do this. Anytime you see a log base 3 and a 3, so basically the log base and the base are the same, they cancel out. So I should have known right away that that equals 2x. Same thing with part E. Now this is an exponential equation, right? Base and an exponent. So if I write it in log form, I've got log, let's say this equals y. Log base 2 of y equals log base 2 of 7, because that was the exponent, which means y equals 7. Or I remember that if I have a base 2 and a log base 2, they cancel, and I get 7 right away. So if you remember the shortcut, you can go faster. If not, you'll follow the steps up here. All right, the last part is using your calculator. So let's shrink this up and move this over here. Oops. No, that's not going to work. So the log of 137. So if there's no number here, it's because it's base 10. Now, your calculator only knows base 10. Because you'll see on your calculator, if you go to the log button, there is no base there. It's because it assumes that you're typing in base 10 of 137 is 2.14. And then we have this ln here. This is a natural log. And then all it means is a log base e. Right? The natural number is e, which we've talked about. So if there's a base e, we don't write it as log base e, we write it as natural log. Either way is fine, but it's more mathematical to write it as natural log. So there's also a natural log button. It's right under the log button, and I'm going to type in square root of 5. Oops. I'm going to get out of the radical, close my parentheses, and I get 0.805. So again, write down any questions that you have. If you need to rewatch any part of this video, please do so. And I hope you're excited to do some practice next time we meet.